tayong bagong project. Ay, ano na naman? Yan. Oh? Ito, gamit ko 741 op amps. Diba? May mga discrete components, switch, tsaka LED, diba? Resistor, capacitor, potentiometer. Ay, ano nga yan? Aba, ay, kabit natin sa supply. 9 volts. Umilaw siya, diba? O yan naman ngayon kung umilaw yan. Aba, hindi mo nakita? Nilagyan ko ng power, umilaw. Ito ang tinatawag na delay on timer switch. Dinidelay niya yung on time ng circuit, di ba? Hindi kagad siya umiilaw. Pindutin natin yung reset button, you know. Di ba? Ano bang gamit niyan? Delay nga yan. Dinidelay niya yung bago mabuhay yung circuit. Teka. At saan na yung ating Ito. Pwede nating habaan yung delay time niya bago siya mag-on. Yan. Reset. O ba? Counterclockwise, umiksi lalo. Habaan natin. Diba? Timer switch. Counter pala dito. Clockwise. Papunta ron. Uy! Isa pa. Habaan natin. Yun, di ba? So, pag inikot mo ng counter, matagal siya bago mag-on. Pero pag clockwise, mabilis. Pag clockwise, mabilis. Di ba? Di ba? Yan ang ating bagong project. Delay on timer switch. Dinidelay niya yung on time ng circuit bago siya mabuhay. Bago umilaw yung LED. We now come to our schematic diagram of our circuit. Delay on timer switch using 741 op amps. So this is the main IC 741. Pin 1 offset null. There's no connection for pin 1. Pin 2 is the inverting input. So here in this schematic, inverting input is with the negative sign, pin number 2. Pin number 3, non-inverting input. positive sign of the triangle. Triangle is the symbol of 741 op amps. Pin number 4 is the voltage negative. Negative supply. Voltage negative supply. B minus. But here in our circuit, we are not using dual voltage supply. We will only use a single voltage supply. That's why pin number 4 is grounded. Because the op amps is we can use a dual voltage supply for the op amps. But here in our circuit, we are using only a single supply of 9 volts. That's why pin number 4 is grounded. 5 offset null. 6 the output. Okay, 7 B plus positive voltage connected to 9 volts. M8 no connection. So this is the pin out of the 741 op amps IC. We can see here that our supply is 9 volts and we have this power LED. Just a power indicator to our circuit to know that the circuit is on with the current limiting resistor of 5.6K to an LED of color red. That is the power indicator. And into our op amps, pin number 2, inverting input. Why is it inverting input? It inverts the input. If this is 1, it becomes 0 to the output. If this is 0, it becomes 1. So it inverts the input. We can see that later on. And then pin number 2, pin number 3. Okay, pin number 2 connected is the capacitor connected to the ground. 47 microfarad, 25 volts. Also in parallel is the switch. This is the reset switch. If we're going to discharge the capacitor, we're going to press the switch to discharge the capacitor. And into the pin number 2, connected is the 100K resistor and connected to the 9 volts. What is the use of this resistor 100K? It is used for charging the capacitor. Okay? Because in charging the capacitor, we need the resistor, of course the capacitor to charge. Okay? Connected in the inverting input. And then we have this non-inverting input. Why is it non-inverting input? Because it denotes a positive sign. Pin number 3, non-inverting input. And connected to the wiper of the potentiometer. This is the potentiometer. Connected to the positive side, 9 volts, and then the other end to the ground. As we all know that the potentiometer it has a knob, and then 1, 2, 3 pin. 1, 2, 3. Pin number 1 connected to the positive supply. Pin number 2, the wiper located and the wiper is the middle pin of the potentiometer. Pin number 3 is grounded. Okay, so when we turn the knob or the potentiometer using the screwdriver clockwise, as if the wiper is moving downward. If it is counterclockwise, it will move upward. Why is it that we need to use a potentiometer into the circuit? What is the need of the potentiometer to the circuit? We use the potentiometer to establish a reference voltage. Okay? Because if we set the potentiometer into this into a certain voltage, if we set the potentiometer, for example, we set the potentiometer here, and we're going to connect a tester from the wiper to the ground. We can there is a certain voltage for this when we connected the tester, and it becomes the voltage reference. For example, if we're going to connect the tester here, and we measure a 2 volts from the wiper to the ground, and the wiper is located somewhere here, and we measure a 2 volts. Now, what is this pin number 6? This is the output. Connected is the LED, output LED with a resistor of 330 ohms, and the blue connected to the output. And then, since we know the voltage across the wiper and the ground, that is the reference voltage. If we set, because it is potentiometer, we can adjust the voltage. If the voltage at the potentiometer BP is about 2 volts, we can achieve the 2 volts by adjusting the potentiometer upward or downward. 2 volts. And now, why is it that the LED is not yet turning on or still off? Because once we power on the circuit, current flows into the power LED. It will turn on the power LED, and then to the 100K resistor, and then to the capacitor, charging this capacitor. So the voltage of the capacitor, BC, if we're going to connect a tester there, we can see a certain voltage. It continuously charging the capacitor from 0 to a certain up to 5 volts. So when the capacitor is already reached the certain threshold value voltage, for example, it already has a charge of more than 2 volts, for example 2.5 volts, because once we powering on the circuit, capacitor now is charging from 0 to 2.5 volts. If the voltage across the capacitor is 2.5 volts, what happened to the circuit? And the voltage of the potentiometer, the reference voltage is 2 volts. It means voltage at the capacitor is greater than the voltage at the potentiometer, because 2.5 volts is greater than 2 volts. If that capacitor voltage is greater than potentiometer, what is now the condition of the circuit? It will now has a high level into the, it becomes a high level into the input, becomes 1, and then the non-inverting 0. So if this is 1, and this is inverting input, it inverts the signal from high level into a lower level, becomes 0 to the output. Voltage of the capacitor is greater than the voltage of the potentiometer. Inverting, it inverts, becomes 0 or low level. If this is a low level voltage, now it will, the LED now will slowly turning on, because the current flows into the resistor to the LED and then inside the op amps. These op amps now will sourcing the current. What do you think? Sourcing or sinking? I think it is sinking because it is now grounded. Sinking. It sinks to the ground from 9 volts, 330 ohms resistor, LED blue, and then current flows inside the output. So LED now turns on as long as the voltage of the capacitor is greater than the voltage of the potentiometer. Remember that the voltage of the potentiometer is adjustable. You can adjust the voltage here. It becomes now the reference voltage. We can adjust the potentiometer into 3 volts. If we're going to adjust the potentiometer to 3 volts, for example, the potentiometer now is located somewhere here at 3 volts. If the potentiometer is 3 volts and in order to make a timer switch, we're going to first reset the charging capacitor by pressing the button. When we press the button, the charge of the capacitor or the capacitor is discharging to the ground. Okay? And it will now start charging. And the moment that the capacitor has reached its threshold value, or the voltage of the capacitor is greater than the voltage of the potentiometer, for example, it reached 3.1 volt, LED now turns on because it has a high level input, and then it will inverts the input to the output, becomes a low level here, and it is now the time that the LED now will turn on because the current flows into the resistor, into the LED, and then to the ground. Okay, dito na tayo sa ating circuit. Yung tester na green connected sa capacitor, positive to negative. Itong yellow tester connected sa potentiometer, wiper terminal 2 to the ground. Diba yun? Wiper gitna, and then ground. And then makikita natin dito na itong ating 741 act as a comparator. Kukompare niya yung voltage sa potentiometer at ng voltage ng capacitor. Pag mas mataas na yung voltage ng capacitor kaysa sa potentiometer, iilaw na yung LED. Tingnan natin. Yun. Diba? Nag-start na ng charging. At bakit ayaw? Yun. So, rines ko na yung switch. Pag mas mataas na yung voltage sa charging capacitor, nagcha-charge, so kaysa sa potentiometer 1.9, yung nakaset sa potentiometer, iilaw yung ating LED. Medyo matagal, di ba? Ang charging. Bakit matagal? Babaan natin ito. Mabagal mag-charge. 0.6, 0.7 umilaw. Di ba mas mataas na yung capacitor, 0.9 volts. Gawin nating potentiometer 1.4, 1.5. Reset natin. Yo, nag-start ng charging. Hintayin natin yung 1.5. More than 1.5. Then 1 point. Iilaw na yan. 1.5, 9, 1.6. So pag mas mataas yung capacitor voltage kaysa potentiometer, umiilaw yung LED. Di ba? Dahil yung ating 741 act as comparator. Kino-compare niya yung dalawang voltage sa input.